Okay, we are working on the section 9.4 for Math 60. And here I'm going to set up my pen working. There we go. Okay, so now we're doing linear inequalities in two variables. So this is linear inequalities based on a line, greater than or equal to a line. Okay, so symbols. All right, the equation always has an equal. Inequalities have or, and then the other way, greater than and then less than, and then also the possible equal to. Rules for solving. Okay, oops, sorry. I'm going to erase that because I don't want just. Where was my draw? There's my draw. Okay, no. Sorry. Rules for solving an equation. Basically, GMDOS. And you isolate variable. The number of solutions of an equation, 1. Okay, inequalities, basically GMDOS, rules for solving, same thing. But we also have to, there's one codicil, and remember, if you multiply or divide by a number less than 0, a negative number, flip the sign. Flip operation, really. All right, let's write that out so it's not so confusing. Okay, I'm going to get rid of those. And come on. There we go. Okay. Number of solutions, 1. Here you have infinite solutions because it's going to be all numbers greater than, and it goes into infinity. Or all numbers less than. Okay, to graph it, you either graph with points, you graph with the slope and the intercept, or 2 intercepts. Those are the ways we've learned to graph so far. All right, so graphing a linear equality. X is greater than or equal to 2. First off, we graph x equals 2. Since it has the equal to part to the equation, you're going to use a solid line. See, the next one doesn't have it, so we'll show you what the difference is. So x equals 2 is that line right there. Now in this it says x is greater than 2. What we traditionally do is test 0, 0. Unless the line goes through 0, 0, test 0, 0. So if x is 0, is 0 greater than or equal to 2? No. So that means we're not going to shade this side. Instead, we shade the other side. Now, I just do a bunch of arrows because if you're shading multiple lines at one time, it gets rather confusing if you're shading. So I usually just do this. You're more than welcome to actually shade it if you wish. Okay, your choice. I don't know why that went away. Why did that suddenly disappear? Because it's, I don't know. All right, I'm not going to worry about it. Okay, now x greater than 2, we graph x equals 2. But since there's no equal to, we graph it as a dotted or dashed line. So instead of being that nice solid line, instead I'm going to do a dashed line. Dot, 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 dot. Now, x is greater than 2, so I'm shading above 2. Okay, so that's the direction. Now we have x is less than or equal to 2, so now we're going to graph x equals 2, since it has an equal to with it, it's as a solid line. All right, so we're going to draw the line at 2 again. All right, now x is less than, so we test the 0. If x is 0 less than or equal to 2? 0 is less than 2, so that works. So now we're going to shade the side that has the origin in it, the 0, 0. Okay, now here we're going to graph x equals 2, but as a dashed or dotted line. Okay, so because of the lack of an equal to in the inequality. So x is less than 2, we test 0, 0 is less than 2, that is a true statement. So we shade the side that includes the origin. Okay, so y is less than or equal to negative 2. So now y equal, remember, crosses the y-axis. So my line is this one. Oops, it's going to be a solid line. I apologize for creating a dotted line. It's a solid line. And y is less than or equal to that. So I test 0, 0. Is 0 less than or equal to negative 2? No, it's greater than. So I shade away from the origin. There we go. All right. Now on this one, y is greater than negative 2. Again, we're going to cross the y-axis at negative 2. No equal to, so this time I do indeed have a dotted line. All right, y greater than, I'm going to test the 0. Zero greater than negative 2. Yes, it is. So I'm going to graph, or shade, sorry, the side that includes the origin. All right, so this is just written out how to do that. Okay, so we're going to graph a few more. Y equals 2x minus 4. So we plot our origin, minus 4, and then we count off our slope. 1, 2, forward 1. I have to make sure it's going up because it is a positive slope. It sure is. And I'm going to put in a few more dots just to make my line a little straighter. If I have ample dots, I draw better lines. Okay, now this is an equal to, so it does indeed have a solid line. Y is less than, so we're going to test 0, 0. 0 less than or equal to 2 times 0 minus 4. Well, this goes away, so now we have 0 less than or equal to negative 4. That is not true. So 0, 0 is not, so now I'm going to shade the area away from the origin. Here I have y is greater than 2x minus 4, so we're going to graph the negative 4, count off our slope. I just keep counting the slope, up 2 over 1, up 2 over 1, and that gives me a bunch of dots, makes my lines look so much better. Okay, I want full lines, remember that. Now I have 0, 0. 0 greater than 2 times 0 minus 4. Is 0 greater than negative 4? Yes, it is. So I'm going to shade the side that includes the origin. Alrighty, there we go. More practice. Okay, remember this kind we're going to graph with asymptotes. So, if x is 0, y is 2. Because first we're graph this. Now it's got an equal to, so it'll be a solid line. So x is 2. Alright. Sorry, there we go. If y is 0, x is 2. Oops, I just did that, and the other one was y was 2. There we go. Okay, so now what we're going to do is we can draw our line through this. Okay, so we want to just double check. X plus y is 2. So if if I had 4 in the x, then y would have to be -2. There you go. And if I have 6, y would have to be -4. There we are. See, we're all making a straight line. Okay, now we're going to try 0, 0. 0 plus 0 greater than or equal to 2. Well, is 0 greater than or equal to 2? No, it isn't. So we shade away from 0, 0. So we're going to shade this side. All right, now we're working on this one. So again, we're going to do intercepts. If x is 0, y is 6. All right, now I'm going to erase that. See, in person, I'd be covering this with my finger, but you can't see that, so I will scratch it out. If y is 0, x is 3. Notice there is no equal side part of this, so I'm going to make a dotted line. All right, give it my arrows. Now we're going to test 0, 0. 2 times 0 plus 0 greater than 6. Well, is 0 greater than 6? No. So now I've got to shade the area away from 0, 0. All right. Okay, sorry. Now, we're going to graph x minus 3y equals 6. So if x is 0, then y is -2, right? 6 divided by -3 is -2. So y is -2. If y is 0, x is 6. I think that's 6. 1, 2, 3, 4, 5, 6. Yes, I just can't read those the numbers are really tiny. All right. Yes, it does have an equal sign, so I do use the solid line. All right, we're going to test 0, 0. So 0 minus 3 times 0 less than or equal to 6. Is 0 less than 6? No. Oh, yes, sorry. Yes, it is. So we shade the side that does have it. All right. Creative little arrow there at the bottom. Okay, now this one needs a inequality, and you know what? Something is telling me I missed that up here. No, I did do the dotted line. Well, there you go. Okay, so first, if x is 0, y, it's -2. It's -8 divided by -2, so it's a +4. So y is a +4. If y is 0, then x is -8. There's my -8. All right, now dotted line or dash is fine. Give them their arrows. They go all the way across the graph. And then we got a test. So I have 0, 0. So 0 minus 0 is 0, is less than or equal to less than -8. Is 0 less than -8? No. 0 is definitely greater than -8. So we do not graph the side that has the origin. Instead, we graph the other side, or shade the other side. There we go. All right. Not too bad, and that's the end. And this was 9.4, which means we start reviewing for the test tomorrow, have tests the next day, and then we have a day to study finals. All right. Have fun.